Hi friends, welcome to B.Tech. So we are discussing about frequency modulation. So while we are discussing frequency modulation, which is very interesting topic, since frequency modulation is mainly used in broadcasting purpose, that is entertainment broadcasting such as in televisions and radios. So being a communication student, we have to know how these frequency modulation signals are going to be generated. So in this video, we are discussing about the generation of frequency modulation signals. Okay, so here there are two methods to generate FM waves. What are the two methods? Which is nothing but indirect method and second method is direct method. Indirect method is also known as Armstrong method. So let we discuss this indirect method or Armstrong method. So finally, indirect means first the message signal is going to be applied to some other signal, some other block, and from the output of that block we are going to generate frequency modulated wave. That's why this method we call it as indirect method. Okay, let me discuss what is indirect method. So if you observe, in this method we are going to generate a narrow band FM. Already we discussed different types of FM such as narrow band FM and wide band FM. So in this indirect method we are going to generate a narrow band FM. Then if you want to generate a wide band, from that method some frequency multipliers are used to increase the bandwidth. Then we can generate wide band FM. Okay, so that's why this method we call it as indirect method. If you observe the block diagram of this indirect method or Armstrong method, this is the block diagram. This already we discussed in narrowband FM. This is the generation of FM signal in Armstrong method, that is indirect method. What is happening? See here, we are going to generate a signal. Finally, which signal we are going to generate? S of t is equal to AC into, which is in frequency modulated wave, AC into cos of 2 pi ft plus 2 pi into kf integral 0 to t m of t dt. This is the signal, that is S of t is equal to AC into cos 2 pi fct plus integral 0 to t m of t dt into 2 pi kf. This is the signal we are going to generate by means of this Armstrong method or indirect method. So what we require? See here, we require integral of m of t. M of t means which is nothing but a message signal. We have to integrate this message signal. That's why I am applying this message signal to an integrator. Which device acts as an integrator? Which is nothing but a low pass filter acts as an integrator. So this message signal is going to be applied to an integrator like this. M of t is applied to an integrator. What is the output you are getting? Integral m of t integral dt. Next, what do we require? This is multiplied with into some 2 pi kf. Already we know that. What is kf? Kf is nothing but delta f by beta. Okay, so m of t into dt into 2 pi. Some product modulator. We are going to use here product modulator along with AC into cos of this one. So for that purpose, I am using this product modulator. One input to this product modulator is integral of m of t dt, and another input is nothing but a carrier signal is AC, 90 degrees phase shift, AC into sin 2 pi fct. These two are what happened? Summed. Sigma. Sigma is here we are having summation. So sigma summed. So finally we are getting this narrow band FM. If at all if you want to generate a wide band, this output is given to frequency multiplier. In frequency multiplier, what happens? The frequency is going to be multiplied. For example, I have FC minus FM. I want some multiplied frequency. FC, either this is going to be multiplied. FM is going to be multiplied. In such case, such type, we are going to design this frequency multiplier n into, so Fc minus n into Fm. Okay, so this is the Armstrong method, which is an indirect method. This is the description like this. Here we are going to, the summer block has two inputs which are nothing but the two terms of narrowband FM. What are the two terms of narrowband FM? One is 2 pi ft and another one is 2 pi kf integral 0 to t into m of t dt. Okay. And second one is nothing but, here how we are going to generate carrier wave. This carrier wave generally it can be generated by means of, remember, anywhere carrier wave can be generated by means of local oscillator. We are having different oscillators. So here this local oscillator is going to be generate a carrier signal having some frequency of Fc with an amplitude of AC. Okay, so this is about the indirect method of FM. And coming to next one, direct method. What is direct method? Directly we are going to generate the frequency modulated wave. Okay, so in the direct method, the instantaneous frequency of the carrier wave is varied directly in accordance with the message signal by means of a device which we call it as VCO, voltage controlled oscillator. As the name implies, as we know that oscillator is used to generate frequency. Oscillator is used to generate frequency signal. Here this frequency is going to be controlled by means of this voltage. Voltage controlled oscillator. Based on the voltage, we are going to generate a frequency signal, having a signal which is having different frequencies. That frequency modulated itself is nothing but a signal which is having different frequencies. Okay, so by means of directly with the help of some voltage, we are going to generate, we are controlling the oscillated frequency. Like this we are going to generate a frequency modulated wave. So this is the voltage controlled oscillator which we are having two inductors and one capacitor, which is nothing but which device acts as, which is here, which oscillator? It is nothing but Hartley oscillator, which is having two inductors and one capacitor. Okay, the frequency of this Hartley oscillator is nothing but 1 by 2 pi into root of L1 plus L2 into C. The capacitive in which the capacitive component of the frequency determining network in the oscillator consists of a fixed capacitor shunted by a voltage variable capacitor. This is nothing but 1 by 2 pi into root of L1 plus L2 into C. By varying the frequency or by varying this inductor, here capacitor is a fixed value. By varying the inductance values, we can generate the frequencies which is having different frequencies, frequency signal. So C of t is equal to C naught plus C into variable of t. Therefore, the frequency of oscillation is given as Fi of t is equal to 1 by 2 pi into root of L1 plus L2 into C of t, where C of t is equal to C naught plus C into V of t. Assume that for sinusoidal frequency, sinusoidal modulating wave of frequency Fm, the capacitance C of t can be expressed as this one. C of t is equal to C naught plus delta C into cos of 2 pi into Fm into t. If we substitute C of t here in this equation, therefore Fi of t is equal to 1 by 2 pi into root of L1 plus L2 into what is C of t we have from second equation, C naught plus delta C into cos of 2 pi into Fm into t. Substitute. You are getting like this, 2 pi into root of L1 plus L2 into, take C naught as common, C naught common is say 1 plus delta C by C naught into cos of 2 pi Fm into t. That is equal to, I am assuming this one as 2 pi into as F naught. 1 by 2 pi into root of L1 plus L2 into C naught as F naught. So F naught by root of 1 plus delta C by C naught into cos of 2 pi Fm into t. That implies finally what we are getting, 1 plus, this can be written as 1 by anything is equal to whole power root. So whole power minus half. F naught into 1 plus delta C by C naught into cos 2 pi Fm into t. See here 1 by root x. Simply I can write 1 by root x as x power minus half, or see 1 by x power half, that is equal to x power minus half. Fi of t. It is in the form of 1 plus x whole power minus half, which is approximately equal to 1 minus x by 2. So that is equal to f naught into 1 minus x by 2. X is delta c by c naught into cos of 2 pi fm into t by c naught. What is delta c by t naught, c naught? Approximately equal to delta f by f naught. Substituting, finally we are getting the frequency as Fi is equal to f naught plus delta f into cos 2 pi fm into t, which is nothing but frequency modulated wave. This is directly with the help of oscillator itself we are going to generate this frequency modulated wave, which is the instantaneous frequency of FM wave. So this is about generation of FM waves, two methods, indirect method and direct method. Hope you enjoyed this video. Okay, thank you.